rods and be able to know the major, what I'm going to tell you right now, the major parts. So these are round-legged rods. This is why we did all this biochemical tests, because each one of these will come out different. Now first, we did do the biochemical test. What would they look like? They all look like pink rods. So that's why we did the biochemical test. The other thing you may need is disease hint. These are going to sound familiar. Bordetella. Bordetella, remember that is spontaneous abortion in animals, but only in cattle. It's Bordetella. It's also in your handout on your microorganisms, it's also in your textbook. It's also gladness. Okay? Bordetella. That is spontaneous abortion. Spontaneous abortion.
That was not brucella?
Yes,
That
brucella.
was brucella. This is
Bordetella
pertussis.
pertussis.
Bordetella pertussis. Thank you very much. That is whooping cough. Yeah, brucella is the other one. Whooping cough. We'll put it right underneath. Bordetella pertussis is a vaccination. Whooping cough. Brucella is spontaneous abortion. But not in humans, in cattle, in several animals, not in buffalo. So why do you about West having a tension between some of the ranches? Okay, Bordetella is Bordetella, and it's pertussis, you know is what we call it. Brucella is Brucella, Cella. That's spontaneous abortion in animals, but not in humans, and not in buffalo. So then people have intention because brucella is in the bison, buffalo, what's going to happen to the cattle next door? It's going to lose all its next generation. Because it's endemic, E-N-D-E-M-I-C, in cat and other animals. This one I'm going to teach you, put up here, and it's also going to be on your view sheet, carbapenem. Resistance, I spelled quite right, I'll get it next time.
This is gram-negative, right?
These are all ground negatives, every one of them. Carbapenem. Resistant enterobacteriaceae. What's the short term for that? CRE. The one I want you to know is the one that's coming out right now, and it is a gram-negative rod, and all of these are Klebsiella. So look at your enterobacteriaceae, Klebsiella is right on that list. In fact, most of these are. And some of them. Okay? Other one, E. coli. E. coli is in your intestine. He's a resident microbe. He can only give you diarrhea if what? He has that plasma. Okay? What's your Yersinia pestis? Black death. Sporadic right now is endemic in some countries. Okay?
This is all CRE.
No. These. This is my one example for CRE.
Okay.
This is black death. Now, remember me talking about epidemiology, and when they changed and mined and looked at the children would have an outbreak of diarrhea from Shigella. There's a lot more than this. I'll give you more. These will still be up here for you to copy. This one's misnamed. What's wrong with it? Homophilus who? What's wrong with that? Flu is a virus. This is a ground-negative rod. Haemophilus influenza. So we have our whooping cough that's coming back, especially in the elderly. It can be dangerous to the young when people do vaccinations. Spontaneous abortion with brucella causes an economic problem in animals, but not buffalo. Haemophilus influenza, misnamed, can be respiratory secondary infection with flu. It can also be meningitis. Coming out of MRSA, your CREs, carbapenem resistant antibacterial rate, our example is Klebsiella flesh. E. coli is everywhere. Okay, it's in your intestine, it's a coliform. Does that mean it ferments lactose or does it ferment lactose? It does ferment lactose. If a coliform is present, what is always present in that water or food sample? Feces. So remember, if it's lactose positive on these tests I'm about to go through, it can be E. coli. E. coli. If it's lactose negative, it can be, I said you do this, but I haven't put this on this before, but I'm going to teach you that. It can be Proteus. Lactose negative is your Proteus. Proteus, still ground-negative rod. Yersinia pestis, carried by a flea on the rats. Rats ran into the homes. People got Black Death. Epidemiology, which we went over, in epidemiology, when they looked at the whole population, they didn't see a problem. When they looked at the children, there was massive diarrhea. It was Shigella. So all these have been taught to you before, every one of them. But this, one of these, what you're going to see is you'll look and you'll see a what? Ground-negative rod. What will you need to tell ground-negative rod from a ground-negative rod? Either the biochemical test, which I'm not going to make you learn, or give some sort of association. Misnamed for flu, okay? Causes diarrhea, all right? Black Death, CRE, lactose negative urinary tract, diarrhea again, whooping cough, pertussis, spontaneous abortion. That's it.
So anything different with E. coli and Shigella, they both cause diarrhea?
No, E. coli, think of it as more as a resident microorganism in your intestine. Only if it has that transgenic phage or plasma doesn't give you diarrhea. Just think resident microbe, lab rat, lab pet. Now, E. coli usually doesn't cause you problems. Shigella will always give you diarrhea. Yes?
I thought if you ate E. coli, it would give you diarrhea.
It can, but I'm teaching you for resident microorganisms. Shigella is a pathogen. E. coli is a resident microbe that can become an opportunistic pathogen. I'm teaching you the resident microbe part. Okay? And it only becomes an opportunistic pathogen if it has the plasmid, which most of them don't. That comes E. coli 0157. Or if you eat it in large quantities and somebody has fecal matter in your hamburger, which isn't usual, I hope. Okay? That's it. So for this one, resident microflora in your intestine. Always a pathogen for diarrhea. E. coli is not always going to give you diarrhea, or you wouldn't be sitting here. Because what's in your intestine right now? E. coli. Would you be sitting here? No, you wouldn't. You'd be in that bathroom and you wouldn't be coming out. I promise you. Okay? If you had Shigella, you would be in that bathroom right now. And as long as it was in your intestine, you'd stay there. Alright? That's the difference. That's the difference right there. Just these. Okay. Remember also, just one thing, when you did your Kirby-Bauer test, Kirby-Bauer test was done on Euler-Hinton honor. Euler-Hinton honor. You're going to hunt for zones of inhibition. Zones of inhibition. You measure the zone through what? Millimeters about the width of a toothpick. Not the width of your finger, the width of a toothpick. Now, Kirby-Bauer, you need to know this, P stands for penicillin, because all the small antibiotic discs were labeled in manufacturer. T is tetracycline. S is streptomycin. And RA is refractant. And you would look at this, and the first thing you're probably going to have to do is you're going to have to measure the zone of inhibition. For an antibiotic, which is also called the Kirby-Bauer test, or the Euler-Hinton, spelled it out because people were asking, Euler-Hinton honors. How do you measure the zone of inhibition? One side of the diameter, all the way to the other side, through the center. One side of the diameter, this is antibiotics only. One edge of no growth, the zone of inhibition, through the center, all the way out to the side. All the way out to the side. For an antiseptic, and I would have to label Lysol or disinfectant. For a disinfectant, I have to label it. Let's talk antiseptics. Use this one. This one has scope, it has Listerine, and it has, what's already sauce?
That's the hand sanitizer.
That's the hand sanitizer. Okay, it worked. It worked. So for antiseptics, and I'm going to correct this on your lab review sheet, it would still give you the same, pretty much the same number because there's only a difference of about 1.5 millimeters. Measure from the edge of the paper disc out to the end. Edge of the paper disc out to the end. And even if you follow the review sheet and measure from the center of the disc out to the end, you're still going to be in my window of measurements for zone of inhibition. Measure from edge of disc out to the end of zone of inhibition for antiseptics. These antiseptics happen to be scope, happen to be Listerine, and others. So what will I ask? This is kind of better. It's kind of different now. You're going to have to know what is antibiotic or antiseptic. Antiseptics will be labeled with the chemical name. Antibiotics will have these numbers on the disc. You will be asked to measure millimeters for zone of inhibition. Know whether they go all the way across or just from the paper disc out. Know to measure millimeters. And be able to tell me which organism is most sensitive to the chemical, which chemical the organism is most sensitive to, and which one is most resistant to. If this was the one, would that organism be very sensitive or very resistant to that chemical? Would the organism be sensitive or resistant to that chemical? Say sensitive, because it killed it. It killed it. That's why it was a zone with no breath. Killed it. Now, if I was doing this one, would that organism be more resistant or more sensitive to that chemical? More resistant. More resistant. Be careful not to mix it up. And actually, people can change it from the chemical's point of view, but I'm not going to do that to you. I'm not going to do that to you. Okay. So on this plate, it would be like A, B, C, and D. Which chemical was, well, the organism is most sensitive to which chemical? You would put A, B, C, or D. The organism was most resistant to which? A, B, C, or D? Well, in that case, if that was D, yes. Does that make sense? Okay, because I'll be sure nobody gets confused on that one. Okay, you were in. Now, for the noble salts otter, that's a different plate. Yes, go ahead.
What plate was the last one?
You were in.
Do we know the name of it?
Yes, because if you do an antibiotic, if you ever see an antibiotic assay, Kirby Bauer is the proper name, it has to be on nutrients and R is invalid. They put it on anything else, it doesn't count. They put it on TSA, the lab results can be thrown out with those.
So what's different between Kirby Bauer and
Kirby Bauer is the antibiotic test. Kirby Bauer is the name after the researchers
It's just
for.
on a new plate.
Yes, it's the same test.
oh, that's a plate.
Yeah, that's
This is
the
the
plate.
plate. That's the
Oh,
plate.
okay.
That's the plate you use for the test. Hand was on. What's your question? No? No? Okay, let's reiterate that one more time because I'm not in a hurry. I'm here to help you understand. This is the plate used for the antibiotic test. You measure zones of inhibition. Is the organism sensitive or resistant to the antibiotic? Now, the proper name, I'll put it up here for the antibiotic test. Let's see. If you ever see this in a lab, it's called the Kirby Bauer test. It's called the Kirby Bauer. Other people don't even call it anymore, they call it the antibiotic test. Other people still stick to Kirby Bauer. You'll see both out here. You'll see both out here. Now we're moving to a different test. I'm not going to make you learn that. This is technically called an underlying test. I'm going to let you call it an immunodiffusion plate. Immunodiffusion. Because what happens? The antigen or antibody that you put in the well diffused out. Right? Diffused out. Now, the questions for this can be several. First is given the type of the plate. This plate is a noble self-solder plate for the immunodiffusion plate. Okay, one word. I'm going to draw way up here. And several things can happen with that. And you'll see this up front. Remember, you made your wells and you load them. You did horse, cow, and pig. I'm going to do this 3 ways. 1, like you did lab, and 2, for applications according to real labs. Okay? You put the antigen in the center, put antibodies on the outside, always like a set. They're always like a match pair. Get one and they match, you're going to get the other one. Now, here, as soon as you have those wells and you load them, the antibody antigen is going to start diffusing out. So it's called the immunodiffusion, like immuno for immune system, antibodies, diffusion for diffusion. You want to form this. What is this? That's that lattice work, antibody antigen complex. If they match. If the antibody antigen don't match, what do? They go right past each other. If they match on a plate, it's considered solid, like someone saying the precipitation tonight is going to be snow or the ice. Precipitation. It's called precipitation. Now here's where I'm going to go. If you want to know what was in the center, you didn't know because it was A, B, or C. And you know that this was horse, cow, and pig. It's actually bovine and swine. Your line, small, pale, white line, that's your antibody antigen complex formed between these two. What was your center antigen? It was horse, cow, and pig. It was pig. Now, that's for practice. What if you had a patient, with your patient you had, say, pertussis, flu, and maybe rabies. The line forms there, that pale white line, which is the antibody antigen complex that they match. That person had what? Pertussis. Bordetella, pertussis. Okay, let's switch again. There's a lot of ways you can do this. This is actually up here on a drawing that another class will do. What if your center was pertussis, and this is patient 1, 2, and 3, and you want to know if any of your patients had whooping cough? What if the line formed there? Each patient has 3. In other words, wherever the line forms, it matches. Wherever the white is a pale white line, there's some here for you to practice seeing. See, now practice that. Where that pale white line forms, that's what you're going for. You'll have part of the answer, and if you have this answer, you know what that is.
And what is the white line called?
It's called line of precipitation. Like we're going to have precipitation tonight when you're going to have rain, snow, or ice. But it means solid. Solid antibody antigen complex. That's okay. The other one I want to go over a little bit is coliforms. I'm going to go over first. I'm going to do something else. Coliforms. They are a group of indicative organisms. They are all ground negative rods, but they're all come from where? Human intestine. Presence of coliforms and even a trace of it in your brownie means you have what?